burned, we just supply primary air, and we will use secondary air to so completely burn is in a furnace, not on the grid. On the grid is incomplete. So mainly is pyrolysis, combustion, or gasification combustions. So like this. And for if we test the combustion or incineration efficiency, we will take to detect the bottom ash. The bottom ash, we say such like the carbon content in the bottom ash should be less than 5%. So we usually use the carbon content in the bottom ash to calculate the combustion efficiency. Or we can use the CO concentration in the flue gas to calculate the combustion efficiency. CO over CO plus CO2. So this is for calculate the combustion efficiency or incineration efficiency. We also actually do some simulation. So you can see here the temperature distributions on the grid. Of course, under the beginning of the grid or the front of the grid, it's just room temperature, 500, 50 centigrade, and gradually increased. So 200, 700, and over 1000, and here is the bottom ash. So for flue gas, we just usually require over 850 centigrade, and the loosening time is over 2 seconds. So this is required for the technical standard. AER means the air exit ratio. So roughly for the greater is 1.3, and for CFB is a little smaller. But for CFB, the air of flue gas facility is more quicker. So we also can see from the vertical, so from this side, so you can see on the surface is combustion, and in the middle of bottom is still raw MSW or drying. So this is the different phase. Okay, the site 3T plus O means we have to supply enough time for combustion. The temperature is high enough, and we have to mix well the the MSW and air. So the grid is moving grid will helpful for mix the MSW and mix the air with how to say supply enough air for the combustion, and oxygen is here. So as we know, some material is combustible, such like in the open dumping site, the MSW can burn, and for the biomass pellet it can burn, and dry newspaper can burn. But as we know, the watermelon peels, the wet wood, and the wet newspaper, it cannot burn, or it is not easily burn, right? So for the MSW actually is mix all the material together, so it's a mixture, complex mixtures. So for the incineration, usually we say if the heat value means low heat value, smaller than 1000 kcal over kg, is impossible for self-sustainable combustion. That means it not can burn longer time, maybe burn some time, it will burn out, right? So this is the typical requirement for the MSW. The low heat value have to higher than 1000 kcal over kg. Of course, not 1000 is not enough. It's only at least, right? So for the design, we have some experience. If we design such like the design feed, design MSW is 1500 kcal over kg. So that means we also can burn some different MSW because MSW is changing, is fluctuating. So for like WT incinerator experience is like this. Usually, the available feed stock usually must be in the range of 70% to 130% of designed value, including LHV and amount. That means the amount cannot too much or cannot too few. If too few, the temperature is not enough. If too much, the temperature will be high, right? LHV is same. So this is the requirement. So during the design, we can get this diagram, how much LHV or amount can feed. So when the LHV is lower, so we can increase the amount. When the LHV is very higher, so we reduce the amount. We just keeping the heat loader in the incinerator or in a furnace is stable or is just in some reasonable levels. So we should LHV times amount equal to the design heat loader for over volume for the incinerator. So this is very important. Very important. So this is the amount. This is the how to say the heat. So we have this area. So for the amount, okay, we can in long time over amount operation, but for the overheat value we cannot. So we should take care. So actually here shows in this the red one is normal operation area, and this yellow one is you can long time overload, but this area you cannot just temporary short time. You cannot such weeks or months. So maybe just some days is okay. So for the MSW, the problem is complex. It's various composition. So it's very difficult to incineration compared to the common fossil fuels, such as fuel, such as coal or the gasoline. So it's some typical difference, including the different density. Because maybe you see the watermelon, the plastic, the density is different, right? The composition is over 10 kinds of the MSW and the different size and the pollution source have chlorine, sulfur, heavy metal in the MSW. And another is high moisture. The moisture, the raw MSW moisture can up to 60 or 70%, and different ignition temperatures, low heat values, high temperature corrosion on the heating surface. So this is the challenge for MSW incinerations. Actually, the MSW, how to say, compensation also is influenced by the economics. Not only as the last literature we mentioned that the amount or the generation is depend on the economic, but actually the compensation also is usually low income. The heat value is lower, maybe more for the West. If the economy is good, the papers, the plastic, especially something like the paper package, is higher. So you also can see here for the plastic, this part, and the papers. So you see food waste, this one. For low income, food waste is higher, 56%. And for high income, only 32%. So of course, it will influence the combustion technology, incinerating technology. That's why, and the beginning development of WT in China, the import grade cannot well works in China because the quality of MSW is quite worse compared to developed countries. So the compensation, we can give some case, some Asia country and region and developed countries. So you see, for the West is lower, for the developed countries. So Singapore also is developed, right? Korea, South Korea, Japan, and Malaysia, China is the highest. And another is not only different country, different composition, also different year, different compositions. So this is Hangzhou. You see, like from 2005 to 2011, the food waste looks changed, slightly reduced, right? And the paper, plastic increase. So it will imply the combustible contact increased and the heat value increased. Here is the heat value, low heat value in Shanghai. So you can see have some slight change, increase years by years. So we also can compare the heat value between different cities and China to different countries. So in Hangzhou, roughly is 6,745 kg. So roughly means 1,500 kcal. Oh, but you can compare to USA, UK, much higher than China, right? So this is same year in different provinces in China also is different. So this is the challenge before you design and manufacture the incinerator for different city. You have to do the sample and analyze the character of local MSW, not only the amount. For the amount, we already mentioned how to calculate the amount. Just how much population and how many or how much one person produced one day, so we can calculate that. Because sometimes the collection is not complete. So the generation is larger than collections. So usually we just focus on the generations. But for amount is not enough. We have to know the heat value. We have to know the sulfur, nitrogen, and chlorine and content in the MSW. It will stronger influence the benefit for the operators, because if the sulfur or the nitrogen chlorine means the pollutant element is higher, the cost will be higher to control the pollutions, right? If the LHV is lower, then maybe the electron production or efficiency is lower. So this is very important for the design for the operator. They calculate the benefit, the cost. So this is very, very important. So how to make the MSW sampling and the character analysis? In China, we have the system standard, such like we have the sampling and analysis method for domestic waste. Of course, domestic waste means municipal solid waste. And we also updated the standard, such like the first time is 1995 and updated in 2009. So I can show the key content of the standard. The standard already set the set numbers for one city. So such like how much population, then how much is set. Such like 1 place, 2 place, or 8 place. For this is a small city, right? 500,000 population in city. Then we should set sampling the MSW 8 place and the sampling weight for the depend on what kind of the waste, right? If the particle is huge, then we should sample more MSW. So usually yes, actually all of like this 200 kilogram. Oh, sorry, I forget the unit. Kilogram. So kilogram. So sampling frequency also set the sampling frequency suggests each month. But actually, you see, if each month and if so many sites means we need to pay more, and the cost is higher. So based on the experience, the industrial experience, we not completely follow the standard, just as the reference of the standard. So the real sampling usually like this: 2 times for 1 year. So rain or dry season or summer and winter. So just given the season, we will sampling 1 times and 2 times for 1 year, but we will sampling 3 samples for one average. So we use the average data as the feedstock values, and we not sample so many sites. Usually only one place in the landfill or the tipping hole of existing WTE plant. Such like if we go to a city, there is no WTE plant, but they have landfill. So we just go to the landfill, we make the sample, we collect the sample in the landfill, and already have the WTE plant. Then we will go to the existing WTE plant in the tipping hole, we get the samples. And according to the standard, the MSBL should divide into 11 kinds, including the food waste, paper, plastic, textile, wood, ash, black, glass, metal, others, and mixed fats. So, but for the WTE, we only collected at least food waste, paper, plastic, textile, wood, uncombustible, and others. These others means too small particle is difficult to separate, or even is impossible to separate, such like the rice, the soil will stick together, right? So this is impossible to separate. So we usually this. Of course, some company will ask us to analyze metal. So will be food waste, paper, plastic, textile, wood, uncombustible, metal, and others. So because metal, they wanted to know how much percentage can be recycled from MSW for the metal. Yeah, this is just some case sampling in China. So this guy is younger me, and both is two of my students in the landfill. So landfill, of course, not only the refuse landfill, we also will sample in some already some years, because now in China we started to digging the landfill to dig the MSW to burn. So we call it the mined MSW. So this is dig out. And we also go to the factory, right? So go to factory, and this is sampling in the landfill site. And of course, sometimes some company, they sample themselves, then they post the sample to our laboratory. So we just get the packages. Then we crush it and separate it. And this, I hope you can recognize where we are. So actually, this is in the ITB gate. I think this is Dika, right? Dika, me, and this is in Bali. I think it's Bali. This is in Jakarta, in UPM, and this is in Yogyakarta, and this is Bandung landfill, and this picture is in Chulalongkorn, right? And we also do sampling in the coast for the marine waste. So you see, sometimes or always the standard, just like a reference, we cannot completely follow the standard. So many times, usually we just depend on our experience to collect the sampling. So this is for marine waste, marine plastic treatment. And we also collect the sample for the sludge, from the sewage wastewater treatment. And this is RDF. and this is food waste, and this is kitchen waste at my home during the pandemic. So I just separate the waste myself and calculate how much is biomass, how much is fish or bone, so separate. And this is the digester from the food waste treatment centers. So if follow the standard about the sampling, we have a different method. Typically, we use this one. So at the beginning, we mix the MSW together, 100 or 200 kilogram. Then we separate. That means we separate like how to say 4 parts. Then remove 2 parts. Use these 2 parts. Then mix together again. Then divide 4 parts. We use two parts. Then mix together. So this is the sample we will to analyze. So we use this to how to sorting for the waste, plastic, textile. So you use this. So this is we will sorting and we will make tables record. So such like here. I think the car is belong to Professor Harry, my student. Dick also is my good student. So we divide 4 parts, right? Use this line. Then we remove 2 parts, use these 2 parts, then mix again, then divide 4 parts, we remove 2 parts. So in the site, we have to make clearly record. So how much for the waste, the weight, how much paper, wood, textile, right? Glass, metal, sand, and others. So you have to make clearly, of course, the location, who, a sample, and the sample data and the sample label. So what the name? So is a Bandu landfill. So shall make record like this. After you collect the samples from the landfill or from the waste to energy plant, so you should bring to the analyze center or bring to your labs for analyze, right? So we also have the standard for general detecting method for the chemical character of domestic refuse. Domestic refuse also mean municipal solid waste. And what character we analyze, including the proximate analyze, so contain the moisture, the ash, the fixed carbon, and volatile matters. So for parameter, always very important. For the moisture, of course, you can know how much water in the MSW, right? If higher, no, of course, we understand the heat value is lower. And of course, we can thinking is necessary to dry or dewater it. For ash, yes, very important. For ash, we can understand how much final residue will be gated, right? For slag ash, or we call the bottom ash, for fly ash, how much? So usually ash is 25 or 30 percentage. And for the termite, it will be easy to judge. It's easy to burn or it's hard to burn. So V over C is a very useful parameter for judging the combustible. And the ultimate analysis, including carbon, hydrogen, oxygen, nitrogen, sulfur, this is typical, but at percent, more company also will analyze Cl and F. CHONS is very important for how to say, for calculator how much air you need supply, and you also can calculate how much flue gas will produce. The flue gas, the air, the calculation all based on this information. So carbon, hydrogen, oxygen, nitrogen, and sulfur is very important. And by the way, during the calculator, the theoretical oxygen or air requirement, we don't calculate the nitrogen oxidation. We only calculate the carbon hydrogen solvent. I don't know why. Maybe usually nitrogen is lower and nitrogen is not easy to oxidation, so we don't calculate. For the heat value, calculate electricity production based on thermal efficiency. Such like usually the thermal efficiency is 25%. So if you know the heat value, of course, you can calculate how much electricity produced from 1 ton of MSW. So you can get roughly values, right? Such like the USA heat value is 4 times or 2 times of China West, right? Of course, the electric production also is higher. And the heat value, just for environmental production is not common, or during the design also is not used for WTE, just for, okay, maybe required by the government, then we detect it. So I not talk about too much about the heat, heavy metal. Heavy metal for the coal, for the sludge is very important. So in industrial, no consider NOx, the oil consumption. And after you collect your sample from the landfill first, you have to dry it. So all the salt waste should be dried in oven with 105 centigrade of 12 hours to constant weight. So after 4 hours or 10 hours, you will wait it. So to watch the mass change or very small change. So if very small, that means already dried. So please make a real record of the waste drying. It is my experience. Before drying, okay, you can understand this is food waste. This is the wood or textile. After drying, all looks similar, so you have to take care, make a record. So another yes, in the sampling drying, we have different bases. So the raw MSW we call it the air received basis. After how to say drying, we can call it air dry basis, because even you dry 12 hours, it's impossible completely dry it. So we just say it's air dry basis. And for calculation, you also have the dry base. That means completely without moistures. After drying, you have to shrink it and mix for simulation. This is very important. Shrinking, it will be make your sample is homogeneous. And the mix is depend on your record. So how much percentage of wood, how much percentage of plastic, then you should mix back together for analyze. And this is some case. This is after drying, and this is oven. After drying, we should how to say use knife to cut it by hand first to make a small particle, but it's not enough. After your hand cutting, you should use machines. So make like powder, right? Much small particles. Is this one or this one? Is same, depending on what you have. And after drying, shrinking, and mixture, you can start to analyze. So analyze the process analyze, including the form, moisture, ash, volatile matter, and fixed carbon. For moisture, it's easy, right? You just driving it and wait and how to say to calculate before and after the quality or the mass difference in the moisture content. Ash detector also is easy. Just use the temperature 115 centigrade for 20 meters or longer, depending on your standard. Actually, you can watch. And the volatile matter is also the same, just the temperature is 900 centigrade. You just burn it. What's the difference between ash determination and VM? Fm, volatile matter determination. Yes, for the ash, you use air, so this bottle is open. But for the VM, you have to cover your sample. So this is cover your bottle. We can call this a bowl, right? Or bowl. So your sample put here, cover it. Then 900 centigrade. And for this, just open it. Air will reaction with your sample, but here just maybe looks like pyrolysis. So this is for volatile matter determination. For the fixed carbon, you just use like this equation to calculate the moisture plus ash plus VM plus FC equal to 100%. So you get a M, you get a A, you get a VM, then you can get a FC. And for the ultimate analysis, we also, especially for the student, they how to usually call this is element compensations. So yes, carbon, hydrogen, oxygen, nitrogen, sulfur, ash plus moisture equal to 100%. So you also, from this equation, you can understand the oxygen in the moisture or the oxygen in the ash is not belong to this oxygen, right? This is can reacted oxygens. So we use this often. The basic mechanism is to balance the weight of water and CO2 because the carbon, hydrogen in the MSW burn it will become CO2 and water, right? We just absorb moisture and absorb CO2 is okay. And for H2O, we use the CaCl2 and carbon dioxide. We use CaO to absorb. But of course, you should take care how to overcome the influence of sulfur, chlorine, and nitrogen. That's why so many bottles or so many U-tubers. So all these is materials for overcome the influence of sulfur, chlorine, and nitrogen. Of course, now we have modern equipment. It's very easy. You just put inside and you will get the result, right? But excuse me, this is just the traditional or the mechanism, right? But now for the automatic or AI, even AI machine is easy. For the nitrogen measurement, it's like this. The nitrogen in MSW, we use hot sulfur acid to how to say digest it. Then we'll get ammonia, hydrogen, sulfur oxide. Then we use NaO2 to become this one, and we heat it from the liquid to the gas. Then we use acid to absorb again, so we can get pure resolution of this. Then we can use the IC to detect it. And traditional sulfur measurement also is the same. So we burn it. We become this compound. Then we use DI water to dissolve it. Then the solid become liquid. Okay, after liquid, we can analyze it by chromatographies. So the traditional sulfur measurement, excuse me, this is oxygen. Traditional oxygen, excuse me, again. Traditional oxygen only use the balance 100 minus A minus M minus C H N S Cl. Then we can get it. Okay, Cl is here. Also is burned. Then but here we have used moisture. So the moisture will make the chlorine become HCl. Otherwise, will become Cl2, right? Chlorine gas. So the basic mechanism is to convert Cl in the MSW to HCl, then use L chromatograph to detect the ion. So then we calculate the Cl content in the MSWs. And of course, we have to detect the heat value. The heat value means the amount of heat emitted per unit mass of the combustion, right? Generally, we use the oxygen bomb calorimeter. It's used to measure the heat value of the MSW, or we can just name it as BHV. And of course, BHV just from the machine, we have calculated to HHV, the higher heat value, the amount of heat released by the complete combustion of a substance and the concentration of result water vapor into water. For LHV, is the heat is released when the generated water vapor remains in the gas phase. This is in the machine, right? This is in the real incinerator because the moisture cannot, the water cannot condense in the incineration, or this part is cannot use. So the difference between HHV and LHV lies in whether the water in substance combustion product is liquid or gas. So we have the equation to calculate a BHV with HHV and HHV with LHV. Actually, I found maybe different country the HHV to LHV is different because we use the data H use 2,500. Of course, here is a percentage, so become 25. Maybe it depends on the industry. Sometimes depend on the flue gas temperature. If the flue gas temperature is higher, that means the moisture temperature also is higher, so will release more heat. So actually, this is depend on different countries. So make constant basis air received, air dry or dried. The basis is very important. Don't make a mess. And for the design, usually use LHV, and different countries have some difference. Depend on the industrial experience. So here is some case of MSW analyze. So you see we have the most the weight and weight ratio and the dry ratio and water contact. This is just by drying. And of course, we have this for the plasma analyze and for heat value. For this, we call the automatic analyze. So we can get this. And this is we done in the gate of ITB. So we have this data. So wood food waste paper. So we original, or we call this is a weight, right? Percentage, how much? Then the moisture percentage, the moisture content of each component. And we also have used this, the dry mass percentage. This is very important for your simulate, for your analysis. You have to mix together back according to the percentage. And this is dry combustible. This is very also important. The real analyze, how to say, sample is use this for your equipment analyze, but you have to calculate step by step gradually. And we can get the air dry basis. And here is a joule and cold. So actually here 1 kCl equal to 4.816 joule. So this is the air received basis, means the raw sample. So you have many steps to analyze your samples, right? But finally you have to supply your data to the industry is this table. Air received basis and how to say raw heat values. you can checking your data is right or wrong or some mistake. So how to check? Just look here, 200. So you have to calculate A plus M plus Cm plus Fc is 100. And A plus M plus C plus HONSL is 100. If not equal to 100, means you make mistake. Okay. Like here, this is supplied by Professor Harry. I think maybe in Indonesia use these equations. For China, we use 25 or 2,500. And of course, if you have not the heat final equipment or bomb meters, so you can use these equations. This is experience equations to calculate the heat value. And for the combustion, the ash also is very important. We should take, because if especially for the biomass, it easily become falling or stacking, so it will stick to the tube, the heat exchanger. So you have to know the character of your MSW ash. So the temperature of melting have 4 kinds: deforming, sulfur, hemisphere, and follow temperature. So like this is original, and after heating will become this, become this, become this. This is very simple. You just use a furnace, make a cone here, and watch. You increase temperature slowly and watch what happens. And maybe they take it 2 times, get the average. Okay, the last, I think I have 10 minutes. Yes. Yeah, 10 minutes. So improvement of MSW quality as a feed fuel. For Chinese experience, because the moisture content is very high, so the quality furnace or operator will store the raw MSW in a keeping hole 7 to 10 days to reduce the water content. For improving the combustion stability, the oil gas is pumping into incinerator. And so here I have some definition you have to clearly understand. LHV of raw MSW plant in China roughly is 1,000 to 1,500 kcal per kilogram. But for the design, they will do like this. LHV of stored MSW enter the incinerator, so will roughly in the range of 1,500 to 2,000 kg. So the business issue here will become like this: 1,000 ton per day capacity of plant, but actually the incinerator only 800 ton per day. And for if 1,000 ton per day capacity of incinerator, the real plant is 1,250 ton per day roughly. So sometimes they will tell you the capacity, just tell you okay, capacity is 800 or 1,000. You have to identify what's the capacity, the plant or the incinerator. So usually they sometimes this this is a secret. Some company they want such like in case some company they have 1,000 ton capacity of incinerator and they just tell you the capacity of plant is 1,000 ton per day, because this is approved by the government. They can burn 1,000 ton per day, but really they can burn more. So the equipment. So depend on the business. Of course, if the MSW is not well, so we can sort it. So we can sort the raw MSW. We also can sort for the digging MSW. So this is a demo dig in Hangzhou, and this is after maybe 5 or 10 years later, land fuel in the site. So we separate it or sorting it, because now many cities started to dig the landfill the landfill already become in the center of the city. So this is just some simple or earlier sorting, mechanical sorting. So first the dipping hole, the manual separator, the magnet, how to the what where how to the magnetic sorting and the shredding and the screen or sometimes do composting, but usually of the separate screen they will for the burn for a simple yes, simple method. So this is just a picture. And for of the recycle the plastic, then can do the raw material, maybe for I don't know what to use for some tools or some basic material, plastic materials. And this is the modern, so much complex. Not only the crusher, they have two stage crusher. So we call it primary crusher or fine crusher. We also use the winning machines, and we have the different winner machines. So this is the plant in China. Before CFB, they will use this the sorting system to increase the MSW qualities. So of course, the raw MSW can burn. While they want to increase the quality, after increase the quality of the MSW, the fuel will become better. Then the parameter for steam will be higher, high pressure, high temperature of steam, and the thermal efficiency also will increase. And another yes, it can be how to say increase the capacity of the plant of the incinerator because most of some uncombustible component is separated. And this is after sorting the steel, brick. This is SRF for incineration, and this is metals, other metals. And the key machine here is the closing. This one is the important. The whole system depends on how much particle can create. So this is very important. Yes. And this is screen. Screen, of course, have many kinds. So usually have the drum screen or vibration screen or dish screen. So this is a drum screen, and this is dish screen. Just separate the small part and the big part. The small part, usually the small part, size is the ash or uncombustible. Big part is how to say organic part, plastic or wood. And this is mechanical sorting. So mechanical sorting have two kinds. One is the permanent and another is electrical. So now usually use the electrical magnetic. It will easy operations. And we know machine, so just depend on the density. So the particle will be here, the brick or metal will be here. So the heavy part is here, the light part will be far, so will blocked by the air. So just use air. And we also develop the biological drying. So before or after sorting, we want to, how to say, quickly ferment the MSW, then we can reduce quickly reduce the moisture. As we know, if we want to reduce 20%, we need 10 days. But if you use the Jones biological drying, will be short times. So, but actually, the mechanism is simple. Just blow air and keep warm of the MSW. So this is just for ferment, Jones ferment or active ferment. So this is the case. So this MSW, so biological drying and sorting or classification and crushing. Then we get RDF. Then for electrical power productions. So we also separate metal, glass, and brackets. And this is some demo plant in China held by Jinjiang Group, a big company. So the heat value can increase to 2,500 to 2,600 kCl over kg. So it will become very good fuels. And of course, the sorting can reduce the emissions. This is from publication, can reduce the dioxin 44.5%. So of course, the moisture can decrease, the chlorine can decrease. So it's good, and also it can increase the operation hours. As I mentioned last class, now the industrial 1 year roughly is 6,400 hours 1 year. If you have used the better quality of the emissed bill, of course, the maintain time will reduce, the operation time will increase. So it also will increase the benefit or the profit for the companies, for the WT plant. So that's all today for my literature, and I will teach. Next is about the waste incineration technology. So I hope you enjoy, and I think I have 1 minute for question, right? So, Professor,
Okay.
this is all my time.
Thank you very much.
Yeah, I think I count all the time.
The material is so much,
Yeah.
so much. Usually I give to the student for 2 or at least twice or sometimes 3 times, but you try to put it in 1 hour. So
I will share
I
the PDF.
I offer to student or all audience, if you have any question, not now, because at 2 o'clock maybe Professor Mian will go to somewhere, will have activity else. Please send your question to me or to Aisha or to Dwi, and then the question will forward to Prof. Mian, and Prof. Mian, I hope, willing to answer the question. Is it okay, Prof. Mian?
No problem.
Okay, yeah. Can we distribute your material to our student?
PDF is okay.
PDF is okay, yeah. The PDF version is already in our site, yeah, and our
Yes.
assistant. Yeah, thank you very much for this time, and we will meet again on Monday in the afternoon, 5 o'clock. Well, please once again so the schedule, the material. Okay, at 17 at 27 September we will have technology for waste incineration, and in 30 September we will have what is that? I wrote already in the chat. Yeah, you can see that.
Yeah, here.
Spoiler card. Yeah, I wrote in the chat, in the chatting. Yeah. Okay. I like to say goodbye and thank you very much to Prof. Mian, and also I like to say hello again to all of my friends from Canada, from Pakistan, from Lampung, and whatever it is I can not say one by one. Yeah, ada Jaya Lingga. This is the man from Jaya. You are man of waste, municipal solid waste. I hope you already met Professor Mian.
Yeah, where are you, Jaya?
Jaya. Jaya is silent now. Okay, I hope Jaya will meet again or next week we will meet again on Monday. Terima kasih semuanya. Kita tutup dulu karena Prof. Mian
Recording
ada
stopped.
kegiatan lain. Thank you once again, Prof. Mian.
Okay, maybe the last thing is, I'm sorry. Next time I will shorten my time, cut my time, and give more time for your question. At least
Oh,
10
okay.
minutes, I will give you, okay?
Yeah.
And see you. See you.
Okay. Right, nice. See you.
See you.
Terima kasih anak-anak sekalian, teman-teman sekalian, para hadirin di sini. Terima kasih, sampai ketemu hari Senin yang akan datang ya. Terima kasih sekali lagi. Bye bye. Wassalamualaikum.